Now, we are discussing about formation of loops, creation of loops in a program using for statement. Before that, we have seen the while statement and do while statement, and then we have seen the for statement as well. Now, the for statement, as we had shown, we had discussed in the last class, it is basically starting to check an expression, arithmetic expression, and then it starts with initialization expression, and then we check a particular condition. So, something like this for some variable, integer variable j assigned some value 5 maybe, and then some expression here, this one is j less than equal to 25, and then here there will be some statements which will be executed, and after that there is a third expression which is altering it, and that can be j assigned j plus 5, all right, and the body of the loop. This is a structure that we had seen. So, now there are some critical issues that are to be noted for the for structure. So, if you look at this, you can see that we are using arithmetic expressions. For example, x assigned 2 and y assigned 10, that is an arithmetic expression. So, similarly, this is a valid arithmetic expression. For j assigned x, j less than equal to 4 times x times y, that is the condition. That means, after some computation, we will have to find out whether j is satisfying this condition, and here j, here probably this is something, this construct we have not shown you. This is I do not like it very much, and initially you did not bother about this. J plus equal to y by x, this is a C structure, say C syntax expressing j equals j plus y by x. So, the whole thing can be written in this way. Okay. So, there is, but that is not important for the purpose of understanding for expressions. So, here is just an expression, and this is equivalent to like this for say x was 2 and y was 10, then this is equivalent to j assigned 2, because j assigned x and j assigned 2 are essentially same. J as less than equal to 4 times x times y, that means 4 times 2 times 10, that means 80, and j equals assigned j plus y by x is 5. So, this is equivalent, all right. So, this is initialization, and this is loop continuation condition, and this is the increment, or I, as I was saying, that this is the modulator or the alteration. Okay. Now, increment can be negative. So, this increment, although we are calling it increment, that is why we should not call it increment, let us call it a modulator, because say the same thing I can write as for j assigned 2, maybe something j less than equal to 80, and might be j minus minus. It can be the case. When can it be? Say for example, if I add, if I want that I will be printing the numbers in the reverse order starting from 10. Okay. So, what should I do? So, can I do this? What I want to do is that I want to print something like 10, 9, 8, 7, 5, all right, in this order. So, simply I can do this repeatedly in a loop. For example, for j assigned 10 and j j greater than equal to 5, j minus minus, and here I just do printf %d \n j. So, what will happen? Initially j is 10, less greater than equal to 5. So, 10 will be printed. Then I go back, I decrement j. So, j will become 9, still greater than equal to 5. I come in here, print j 9. I again decrement j becomes 8. I compare with this, still it is greater than equal to 5. I get in and print it. In that way I can do it. I can repeatedly do the same thing, but here as you can see I am being able to achieve this reverse order by, instead of incrementing, I am decrementing this index. That is why I can increment, decrement, I can multiply it, I change it, I modulate it. That is why this to be an alteration expression or modulation expression is a better term than increment or decrement. Okay. So, if the loop continuation condition is initially false, then the for structure will not be executed. It will proceed with the statement for the next statement. So, for example, if I write something like this, as you have seen earlier, j equal to 20 and for I equals I assigned 1, I greater than j I plus plus say, and then I want to do some things here. All right. Now, j is 20, I will first initialize I to 1 and immediately I find the first thing that I do is it is false. I check this and it is false, I is not greater than j. Therefore, these statements will not be executed even once, and the statements following the for loop will be executed. Okay. So, now here are some examples of for loops. This is again computing the factorial. Factorial is the variable, fact is storing the factorial. Factorial, all of you know, is factorial n is n multiplied by n minus 1 multiplied by n minus 2, so and so forth up to 1. So, it is 1 and I have got a variable I. Now, you can see simply I can do it like this, I assigned 1, I less than 10, I plus plus, fact assigned fact times I. Now, what is happening here? So, I have got fact to be 1. So, I equals 1, then with that what I do is 1 times 1 is fine, and I then make I to be 2, and then so I becomes then 2. So, 1 times 2, then I becomes 3, then 1 times 2 times 3, then I becomes 4, then 1 times 2 times 4 times 3 times 4 and so on and so forth, it will go on in this loop. Okay. So, that is a nice way of writing factorial. And here is another example. You can see what it does quickly. You can explain it yourself what it does. Sum is 0 and n is a variable and count is another integer variable. All right. Sum is 0, n is a one variable and count is another integer variable. Now, we are reading n, and for I equals 1, I less than equal to n, I am adding sum. So, what is being done here? What will happen if I trace this program? What is going to happen? Let us do that. Suppose I have read n to be here, I have read n to be 5. Now, what am I doing here? Here there is one problem. Here I should have been declared. There is a mistake here. Int n, and here I also add I. I should have been declared here. Now, I assigned 1. So, I is 1. N was 5, I less than 5, less than equal to 5. So, sum was 0. So, sum is 0 plus I times I was 1. So, 0 plus 1 square, and then I check, I increment I. So, I becomes 2, I becomes 2, and I check that I is less than not less than is still less than equal to 5. So, I got this sum, and with that I add now I square, I times I. So, 2 square. Similarly, it will go on, it will do 3 square. So, I will become then 4, and then still it is less than equal to, so 4 square. Then I will become 5, and still it is true. So, it will be 5 square. Then I become 6, this condition will be violated, and I will come to this printf. So, what will sum be? Sum is 1 square plus 2 square plus 3 square, and if I make it n, then up to n square. So, this is the very well known series, the sum of the square of natural numbers we can compute by this small program using for loop, right. So, it is a nice example. Now, we introduce the comma operator. As we say that here, for, when we write for, then I assigned 1. Instead of that, I can put in more than one statements here using a comma operator. For example, for fact 1, I equals 1, I less than equal to 10. Now, this part is what? This part is the initialization. Okay. Now, remember that this will not be continuously initialized. This is just a statement that I have put here, an assignment statement, but my index variable for the control variable for the loop is I. So, I could have written this earlier example of factorial, maybe earlier example of factorial, this could be initialized here also, all right. So, that is just saving space, saving the number of lines of code, but personally I would suggest, as I did earlier also, that for those of you who are beginners in programming, you should not try these tricks or should not try this thriftiness, reducing the number of lines. That is not so important, how much you can reduce. The most important thing is to be logically and syntactically correct while you write a program. Okay. So, we can give several things in comma, like sum here again. So, the program becomes even smaller, looks smarter, but sometimes at the beginning if you try to do that, you try to be smart, and in the process you may result in some wrong program, wrong logic. Better avoid that. Now, infinite loop. In general, what is an infinite loop? When a program continues in a loop repeatedly, it goes on and it's never completing, it's going on, because the condition that is supposed to turn out to be false at a particular point of time, so that it comes out of the loop, never happens. All right. That can always happen, that say if I write something like for I equals 1, I less than n, and whatever I plus plus. Now, every time inside the loop, when you get in, you do something and then increment I, and when you come inside the loop, you do I minus minus, say. Then whatever has been done here will be cancelled out here. So, this loop will never reach this condition I less than n. Therefore, that this loop will continue forever. Such situations are known as the condition of infinite loop. Now, sometimes, usually we do not like that, but sometimes it may be necessary to specify that something will happen forever, all right. Say some particular work has to be done continuously. Now, in order to specify that, for loop provides us some facility, like say for and while everything. Say this one we had discussed earlier, while 1, that means always it is true, it is non-zero. This while loop, this expression part, condition expression part should return non-zero, and so it will go on. Now, here for and I put null, okay. That means the for has had 3 parts. For the initialization part, some condition part, and some incrementation, decrementation part, whatever. Now, I just keep everything blank. So, I turn it to be for nothing and nothing, all these things are blank. In that case, what will happen? In that case, what will happen? If I keep some statements here, that will go on forever. Okay. Similarly, if I, in the case of do while, if I just put while 1, that is again infinite loop. So, by this I can express my desire that some things will should continue forever, all right. So, this is another trick that you can utilize in some cases for the for and the while constructs. Now, we come to another statement which we have encountered a little few lectures earlier in the context of switch statements. While we are considering the switch statements, if you recall, you have seen that after every case statement, switch on a particular variable, then there case red, case green, case blue, if you recall, then we did something and then gave a break, did something, gave a break, like that we proceeded, right. So, the break statement, of course, we know can help us, we can use it with several things. One is while, do while, for, and switch. Now, this switch part we have seen, but we can also use it for while, do while, and for breaking out of the loop. We want to break out of the loop. Sometimes that is required. It works with while, do while, for, but does not work with if and else statements. Okay. It causes immediate exit from a while, for or do while or case. We have seen that switch statements earlier. So, the program continues after with the next statement. Let us see why do we want to use it? It helps us to escape early from a loop. Sometimes we want to escape early. I do not want to go till the end of the loop. When a particular condition is met, I want to come out. I am doing it in a loop, but waiting for some condition to take place. As soon as that condition takes place, I come out of the loop. Okay. Maybe as we have seen in the case statement, switch some expression, all right, color, then case R, we do something and then give break, right. Case G, we do something and then give break, right. We do like that. So, we skip the remaining part of the switch block, all right, we come out of that. So, similarly, we will see a couple of examples of this. Say here there is a complete example. Let us look at that. Here is a complete example, complete program. Once again include stdio.h, you are running some programs, main, then fact and I are integers, fact we are computing factorial. So, fact is 1, I is 1, while I is less than 10, that means I want to break out while I is less than 10, fact times I. If fact is greater than 100, then factorial is above 100, factorial of a number is above 100. So, for example, I am going on up to 10 numbers. So, what will happen with the factorials? Let us see. So, factorial 1 will be 1, factorial 2 will be 2, factorial 3 will be 3 times 2, that is 6, factorial 4 will be 4 times 3, 4 times 6, it will be 4 times 3 times 2. So, 4 times 6, that means 24, then 24 times 5. So, that will be how much? It will be more than, how much will it be? If I have got this 432 and multiply that with 5. So, 20, 60. So, here just with 5 numbers I am exceeding the value 120, but I do not know when I am going to reach the value 100. So, I have written the program in this way, fact while I is less than 10, I will test it up to 10 numbers. Every time I compute fact, if fact is greater than 100, print. So, here as soon as fact becomes 100, we will say factorial of 5 is above 100, factorial of 5 is above 100, and then I break out. Otherwise, if I had not put this break, then this would have continued till this loop for all the 10 numbers up to factorial 10, but I just want to stop whenever my result becomes more than 100. So, this is one way we can utilize break, right. Similarly, there is another statement, although we do not use it often, it is better to know that sometimes it can come handy. There is a continue statement. That means, the remaining part of the body of a loop we will skip if I put a continue, all right. So, let us see and it proceeds with the next iteration of the loop. So, what happens is, let us look at one example here. So, while 1, that means what? That means it is always true, it will continually go on doing it. So, fact is fact times I plus plus. So, I start with I 1, then 2, then 3. If I is less than 10, I will go into the loop, otherwise I will break. So, this continue is basically remain forcing me to go back to this point by forsaking this part. I am not coming to the remaining of the loop, but if this condition is not holding, then I will not execute continue, I will straightway come here and do break. I think it will need a couple of moments for you to just realize what is happening here. All right. So, just look at this. So, in this way it will I think you can understand it. So, I have got I to be 1. So, fact will be 1 times 1, then I becomes 2, and then I go back. So, it will be fact will be 1 times 1 times 2, I will be 3, and in that we will go on, but it will go on as long as I is 10 less than 10. Then I will not come to break, I will go back here, but if I is less than 10, I will come to break and I will come out of the loop. Okay. So, it is a combination of continue and break. This is, but what I want is that you should understand how the for loop is used for repetition. That is very important to understand, and we will carry out with some examples in the next lecture.